Point-slope form. The point-slope form of a linear equation is in this format. Y minus y1 equals m parentheses x minus x1. M is still going to stand for your slope, and the x1 values and the y1 values are going to stand for a point on your line. If you look at this example, this point is the one that they use, x1 and y1. In order for you to write this equation, you need to know the slope of the line and you need to know what a point is that's on your line. So you need those two pieces of information. You need to know that. Equations, however, are typically not left in point-slope form. It's kind of just an intermediate format for us. Most times you'll be asked to algebraically manipulate it into slope-intercept form. So it says write an equation in point-slope form for the line that passes through negative 2, 3 with a slope of 4. This is your x1, y1. Go back to your form. Y minus y1, which is 3, equals m, your slope of 4, parentheses x minus x1, which in this case is negative 2. We're not going to leave the minus and negative 2 even in just point slope form, so we have to clean this up. Y minus 3 equals 4 times x plus 2. That's the point slope form. In order to change this into slope-intercept form, we're actually going to have to kind of work with it here. So we have y minus 3 equals 4 times x plus 2. On the right-hand side, you can hopefully see that we need to distribute. So you're going to have y minus 3 equals 4x plus 8. Slope-intercept form, just to remind you, y equals mx plus b. Y is by itself. Here, y is not. You have to add 3 to get it by itself. There is a like term over here, so we'll put it right underneath. We stack them together. Those cancel out. Y equals 4x plus 11. Write an equation in point-slope form and slope-intercept form for a line that passes through negative 1, 2, x1, y1, and has a slope of negative 1/2. That's my m. So y minus y1 equals m times x minus x1. Again, not going to leave it that way. Y minus 2 equals negative 1/2 times x plus 1. Minus a negative becomes plus. This is point-slope form. Let's transform it over to slope-intercept. Y minus 2 equals negative 1/2 x minus 1/2. To get the y by itself, we have to add 2 to both sides. Y equals negative 1/2 x. 2 is actually the same thing as 4 over 2 to make common denominators here, right? Negative 1/2 plus 4/2 is still going to give me 3/2. We can just leave it that way, perfectly fine, no need to change it. So there's slope-intercept and there's point-slope form. Next page in your notes, next example, says write an equation in point-slope form and slope-intercept form for the line that passes through these 2 points. You have 2 points. I'm going to recommend using this one. Y, both of the numbers are positive. That was just a mark that I made there. So this is going to be my x1 and that's going to be my y1. You'll notice though I'm missing something, my slope. Remember your slope formula is y2 minus y1 over x2 minus x1. That's slope. We have 2 points. Let's just call this x2, y2. So to find your slope, you're going to do y2 minus y1 over x2 minus x1. 9 minus 1 is 7. Negative 2 plus a negative 8 is negative 10. Your slope is 7/10. Y minus 1 equals negative 7/10 is x minus 8. There's point-slope form, so there's your first answer. And then we're going to start to transform. Y minus 1 equals negative 7/10 x plus 7/10 times 8. Simplify. You're going to get 28/5. We'll leave it that way. We have to add 1 to both sides. Y equals negative 7/10 x. This would actually be 5/5, so that's going to give us plus 33/5. Last example here gives you 2 points again. However, they're in different kind of different setup. So if we look at this, this is actually the point 5, 165, and the point 10, 290. So, slope. We can do 290 minus 165 over 10 minus 5. 290 minus 165 is going to give you 125. 10 minus 5 is going to give you 5. Your slope is 25. Point slope form. Let's just use the first one. Numbers are a little bit smaller. Y minus y1 equals m times x minus x1. There's point slope form. That's all it needs.